gaan nu door met iets waar de universiteit voor is, namelijk een college. En het is een college door Maarten Waterloo. En ik denk dat hij misschien zelf best kan uitleggen waar het over gaat. Het is opgezet dat het heel toegankelijk is voor ook niet-aardwetenschappers, niet-hydrologen. Gewoon voor de geïnteresseerden.
Yeah, okay, I'll do this in English because we have international students, so they should also understand what we're talking about. I was asked just after 12 o'clock this afternoon to do a presentation, and I thought, what should I do? And this reorganization affects the whole of earth sciences and also other educational programs in FALW, but if we look into the future, it might also affect other studies like theology or literature studies that might already have been affected previously. So it's not only about hydrology or earth sciences, it's much broader, as the students who are in the Actiegroep Titanic already have mentioned. Now, we are talking about quality of education, and I selected this topic, water quality, because at the moment, this is the only university in the Netherlands where you can study this. And if these plans continue, this will be impossible in the future. So this would be the last year that you would have hydrochemistry, which is related to this topic. And it would just stop in the Netherlands. Whereas I'll show in this presentation that water quality is a very important issue, not only for hydrologists or geologists or other people studying here, but for humanity as a whole. Okay, water quality. The presentation will have a few topics. I'll look at natural water quality issues first, and that has to do with earth sciences. And after that, I'll look to the quality that or the water quality that we are changing as a society. So we have two aspects, the natural part and the future part or the present part, in which we play a large role in water quality. Okay, first, water quality issues are important because about 14,000 people die every day worldwide of water quality issues. So that's a huge health issue. That's probably not known to everybody. There are two processes that determine water quality. The first one is the geology, and the second one is that we as humans also deteriorate our water quality. And we recognize a few types of water quality issues. These are microbial, so if you go to the toilet, there are a lot of microbes exiting which can make other people sick if you don't have a good sanitation program. The second one is chemical. If you have a factory that uses chromium, for instance, think of Aaron Brockovich movie, that will also affect health. Then we have oxygen depleting materials that are affecting water quality in a way that aquatic life suffers. If there's no oxygen, you can't have fish living in the water. And we have nutrients, so you get algal blooms or botulism, these kind of things that affect health. And finally, we have suspended matter, which can be an important water quality issue for your drinking water. You don't want to have muddy water from your tap. Now, one of the things that wasn't recognized, I think, by most people, is that some of our students have made stickers with non-potable water and placed them in the toilets, and people thought it was serious. So it's a nice sidestep. But that also has to do with water quality. If your water quality is bad, you cannot drink it. If you drink it, you get sick, and that is a big problem. Certainly if you're an infant below 5 years old, because then the chances that you die are a lot bigger than for adults. Okay, let's take a look at Holland, the Netherlands. Here you see all our drinking water pumping stations, and you see what the pH, or this is the electrical conductivity, and you need to drink fresh water. So this conductivity has to be within certain ranges. If it's too salty, you can't drink it anymore. The second one is the pH, and you see a nice distribution. What you can also see is that in this part of the Netherlands, we get our water from the dune areas, and in the eastern part, we get it from groundwater. And groundwater is one of the topics that is dominant in VU hydrology. Okay, if we would plot all these pumping water station water quality data in a plot, then you can see that these blue dots are from the Dutch water supply companies. And water that you get from your tap needs to have a few conditions. It shouldn't be too salty, and the salinity is indicated by the EC, electrical conductivity. And it should also not be too acidic. And why not acidic? Yeah, sure.
We hebben net een overleg gehad of een mail gehad van Jaap Winter en Bert, dus we willen graag even overleggen met een paar mensen.
Okay.
Is Michel er?
Ja.
There will be a short meeting between the dean and some people. So.
Ja.
Succes jongens!
Good luck. Okay, now I'm curious what will happen. So what you see here is that this is drinking water quality. It has strict ranges. And it shouldn't be too acid because our distribution system, the tubes, cannot withstand the acid. They would corrode. Now you see that there are places like Fiji rainfall, the Rio Negro in the Amazon, the Zaire River, which already fall out of the regular water properties for distributing to your homes. And we can also see that the Pacific Ocean and the sea and the Dead Sea are very saline and obviously not suitable for drinking. So we have a few other streams here which I'll discuss later. And you have these 4 red dots. One of them is milk. So milk, if you would put it through your pipes for your tap water, would be okay. Then the next one is caramel. It's a bit more acidic and the EC is already quite high. Then we go to fresh orange juice. Now, this could already dissolve your teeth if you drink too much. And if you have Fanta or cola, clearly these fall outside the water supply limits. But everybody drinks these things every day. So it doesn't mean that the water quality is only depending on EC or pH, but there are other factors like taste. Okay, so let's take a look at natural extremes. And this is a very nice volcano lake. You can see that from the colors and the sulfur that exists. And this is in the island of Java, Indonesia. And there was a VU ecologist who worked together with the hydrologist to do this study. And she studied this lake, and this lake has an extremely low pH, 0.2. So don't put your hand in it because you will get burned. And that's a natural contamination in a volcanic region. So clearly this is not something that you want to drink right away. What happens is that this lake, water is leaving through the crater wall and seeping into rivers. And these rivers flow downstreams and they enter in the Bayuputi river system. What happens there? Now, if we go from the highest point, from the crater lake, you see the low pH, and we move downstream, then you can see that while this water moves downstream, it gets diluted. Because there's rainfall, there's contribution from other sources. So you see that the pH goes up to about 4, which is still quite low. And you also see that chloride, aluminium, iron, and fluor are going down. Now, the last one is problematic, because fluor, if you take in too large quantities, can be not very healthy for people, to say the least. There is a disease that fluor, if you take in too large quantities, it will affect your bone structure, and that means that you go and walk like this when you drink this water. It will also affect your teeth. We had fluoride in our water before. It's now removed, but that was in a very low concentration, and then it might help your teeth. So what is in this river, where people use water from, what they do is they use this water for food production so that fluor comes into their agricultural fields and in their food, and they also use it for drinking. And the metals and fluor concentrations are 11 milligrams per liter. And this is well above the fluorosis limit of 4 milligrams per liter. Now, these people live in an area where you don't have access to other clean drinking water. So these are forced to drink this water. So not all contamination is man-made. We often think that we are the only people or things polluting stuff, but nature can do a very good job by itself as well. Okay, so that's the natural part. Now let's take a look at Bangladesh. Bangladesh is a very poor country. It has a lot of people, 133 million people, so about 10 times the size of the Netherlands. It floods in the wet season. It has a very low-lying delta area where there is a lot of saline water, salt water in the soil. And in the 1960s, there was a plan. Let's help these people. Let's create a well program that these people don't suffer from contaminated surface water, but let's give them clean drinking water. And this well program was established, and people were drinking that water. And this water comes from a geological area that has been influenced by changes in sea level, as we have in the Netherlands. So when the sea level was about 120 meters lower in the past, there were deep valleys incised in that country, and these were later filled with clays, peat, sand, and so on, and now serve as very good aquifers, like the ones that we use in the Netherlands as well. So these are nice places to extract water from, and in fact, in Bangladesh, water is pumped from close to the surface to 300 meters deep. So they have now a nice program with a lot of wells and pumps installed. However, in 1993, it was discovered that the levels of naturally occurring arsenic were much too high. In some places, not everywhere. So that created an immediate problem. And the possible sources are geologic. It has to do with pyrite oxidation and other chemical processes that we're not going to discuss here. But this type of processes occurs normally in Holocene aquifers, and we can have the same problems in the Netherlands. And in fact, North Holland has wells where you can have too high arsenic concentrations in the water. Okay, now the groundwater arsenic concentrations are between 2 and 3,200 micrograms per liter. And the World Health Organization specifies that you should not exceed the 10 microgram per liter limit. So you can imagine if you drink something with a concentration like that, that you can have a problem. So a survey of these wells showed that about 40% of the wells dug in this aid program by the World Bank and others were not of good quality. Good. You see here 2 of these wells. Can you spot the difference?
Left one is green.
Yes, the left one is green and the red one is, the right one is red. What you see is that the green one is okay. Arsenic levels are low. But the red one, arsenic levels are high. And what should be surprising is that both wells are used for getting water from. People know that the water that they get from the red one is toxic, or in the future could be toxic. The problem is that there's not a good alternative for them. So that's a very difficult issue. Are you going to give your children the red type of water, or do you get surface water with microbes and all other kind of contaminants in it? You have to make the decision, and apparently people still decide, well, we'll use the red one in spite of the fact that it has too high arsenic concentrations. Okay, so red ones are not good, and if we were there, we would buy bottled water and not drink from the red ones, I think. What can happen if you do drink over longer periods from these red wells? Well, about 46 to 57 million people do this on a daily basis. And you can see what arsenic will do to your body your skin gets affected, and I think your internal organs will also suffer. So it's not a very nice disease. Now, are there alternatives for these people? At the moment, not really. So they still have to keep drinking this water, and in the future I hope that we can provide them with better drinking water. Now, there is no money at the moment, Bangladesh is very poor, to make deeper wells in the Pleistocene aquifers, which might have good water. And at the moment, the VU is involved in a project which tries to provide alternatives. And this project is called Managed Aquifer Recharge, it's MAR for short. And that's that you infiltrate fresh water into the soil to replace saline water which is now in these aquifers. And here you see how it goes. This is a pond with fresh water. It gets infiltrated in wells, goes into the subsoil, and when you need it, you can take it out in the dry season. So this provides an alternative. Now, there's one good thing about this. If you do such studies, you need to collaborate with local people, with the government, with aid organizations, with everybody who has something to say in the area. We call these stakeholders. So this is a very interdisciplinary, very societal relevant project. Now the strange thing is that the hydrology research line has been abandoned, and that means that the VU does not want to sign for this project. We have gotten it from NWO in December, Koos Groen in front here, and the VU does not want such a project, which is really what the VU should stand for. Working with society, changing people's life for the better. And this doesn't happen now because of this reorganization. So that's one example where you should, as a VU, think about yourself and say, well, is this what we want? Okay, there are other places on Earth where you could also use this technique to get rid of arsenic water or to improve water quality. And these are given on the map, so it's not only Bangladesh where that happens, but there are other developing countries where you could do this. And studies like the ones that we proposed are important for improving people's life. Okay, so what happens in the Netherlands? If we would make wells here, would we suffer from the same problem? Okay, the Netherlands, aquifers are made of sand, we have river clay, where you have agriculture, land use, peat, and so on. So, in principle, if we would have follow the environmental law of the European Union, a lot of our groundwater would be toxic, and we would have to clean it up. And that's for natural circumstances. Because of our deposits in the past geologic time, we have too much arsenic in our groundwater as well. We have the fortunate luxury of not having to use it. And if we would have to clean it up, it would be very costly. So we are not cleaning it up, I guess. Okay, then we come to our own impact. And you see here a very nice image of a garbage belt, and you can imagine that there are lots of contaminants coming out of this garbage dump. If we look back in time, we have started in the 1850s, where we only made some poo-poo, and that would cause a lot of microbes to be released. After that, the Industrial Revolution and our development. So we had problems coming into effect at later stages. Metal pollution, eutrophication, radioactive waste when we had the H-bombs falling, nitrate pollution from fertilizers, for instance, organic micropollutants, and acid rains in the 1980s. So we have continuously changed our environment, and not always to the better. Okay, let's take a look at nitrate. If you give nitrate to a baby, nitrate is active in the process of the red cells, blood cells, to get their oxygen bound. And if you have too high nitrate, then that means that you can't take up oxygen in your blood enough. And that means that babies especially turn blue because they are close to suffocation. So it's called the blue baby syndrome. And the source is either from fertilizers or agriculture or from waste products. Take a look at the Netherlands. When we see here, these are our drinking water wells, and these are between 1900 and 1920. And you can see that we have very low nitrate concentrations, and this is between 1990 and 2002. We have a lot more groundwater extraction, but we can see no problem at all, right? They're all still blue. So, don't we have a nitrate problem in the Netherlands, or do we? Now, this is deep groundwater that we use, we pump up. And if you look at the surface groundwater, then we see, and this is the water traveling downwards into the soil to these deep aquifers in some cases, that we have a problem in our surface water. And this is the basis of water that we'll eventually use. So this might be a problem in the future. We don't see it yet in our deep groundwater, because it takes a lot of time to travel through the soil, but in the future you might get problems. And in fact, the image that I showed you before, all the wells that are already closed because of high nitrogen are not shown anymore. They are just closed and they don't analyze them. So we already do have deep groundwater pollution with nitrate. And then the latest fashion, the pills, Viagra, high blood pressure medication, anti-epileptica, aspirin. We all use them sometimes. You need them to stay healthy. And this is now coming, also becoming a problem. If you look at the news, and then you will see that sometimes articles will appear about drugs in our drinking water or in our waterways. In fact, what you could say that the Rhine River is a very big sewer. We treat the water before it enters the Rhine River, but we often fail to take out the micropollutants like medication, because we don't work on these pollutants. So how do these get into the system? Well, first we have our own medication. I'm on high blood pressure medication, and every morning I have to sleep. I have to take 2 pills, and probably during the day I excrete a little bit of that medication in the sewage system. We also have a lot of animals, and animals use antibiotics and all kinds of other medication to stay healthy, the biofarms. So these things are in a cycle, and finally, where does it end? Somewhere in your drinking water. Now, lately, KWR, Peter Stuyvesant, has been analyzing these medication in our Zandvoort June drinking water. And then you can see that we have medication against epilepsy, against schizophrenia, against, we have antibiotics, we have medication against rheumatism, already in our drinking water. These concentrations are really low, so probably nobody's worried. And I don't think every day that you think about, well, I'm taking a medication against schizophrenia. So that's still good. But there is a quantity that we can already measure. And if you're a homeopathic medication user, we have the infinite dissolution. Do I say that? Yeah, dissolution of stuff which would be very healthy. In that effect, I think we all in this room and the whole of Amsterdam should not suffer anymore from any diseases, because we are treated every day when you drink your water. Okay, so authorities say there's no problem at all, right? You never heard about this problem. Homeopathic, we don't know. Apparently, we still have people being sick, so it doesn't work too well. Now, the problem is that we have quite a kind of large body mass. I'm close to 100 kilograms. What would happen if a guppy fish would swim in this water? Right? He would have, or he, she, the fish would have the same dose. Would it then suffer? Because the guppy fish maybe is a body mass of 1 gram. And does that change the metabolism or change the fish? And if you use a cocktail of different medication, because all these evaluations are for single doses of a medication. It's not that you take a whole cocktail to go against AIDS, for instance. that they can strengthen each other's effect. Okay, these questions are really not known yet. But for the guppy fish, we can have some answers by just looking into our ditches and into nature. Right? So if we go to the USA, we have egg-growing male fish. Strange. In Maryland's Potomac River. We have from 82 male English sole and horny-head turbot in Los Angeles, 11 possessed ovary tissues. So these are going transgender, right? Some people would like that it would happen like this, but these fish naturally, just by taking medication and contaminants in water, have this tendency already. In the UK, a bit closer by, we see the same things happening. So there are problems already in small animals living in these polluted waterways. Now, this is a slide I made some time ago when Balkender was still our Prime Minister. And if you read the CDA election program, then you see that, well, our pollution is not produced in the Netherlands, it comes from outside. So that's a good reason not to do anything in the Netherlands about the environment, right? Because it comes from Germany or Belgium and so on. So that's the program. Now, if we look at Dutch rivers, male fish and shellfish show gender changes already in our rivers. We have anti-fouling, which you use on boats to change shells. And we have boron holding fire retardants, which are mandatory by law, so that your couch doesn't burn too quickly. But if you burn it as waste, it will be found in fish eggs and so on. So we are also polluting our environment through a legal way, because we use these retardants in our material by law. Okay, now the conclusions of this is that we always say we are the cause of pollution, but natural rivers can also be very polluted. If you go into the Rift Valley, you'll have a lot of problems with fluoride as well. So there are natural conditions, geological conditions that lead to high concentrations of things that hurt you. On the other hand, in the Netherlands, our agricultural way might constitute a problem for the future in terms of nitrate, and we have to close our water well system then. And medication, this is only the start of a new field of research. And I think in the Netherlands, we should have some university, somewhere, some group, who studies this, and that students can also study these problems. Because if we stop it at the VU, I hope that some other university will continue with this, because they see a niche. But if that doesn't happen, you have to go abroad to study this. And I hope that's not necessary. Thank you.